Hopefully everybody can see my presentation. Amy, can you see it?
Sorry, I had you on mute. Yes.
Fantastic. Okay, so I'll just put this in presenter mode. And so basically, for the group, I'm just going to actually walk through a quick agenda. So make some introductions. I'll tell you a little bit about risk thinking, myself and our team. Give a quick presentation on how, and this is more philosophical, but then show you how we do it, but how to understand and how to calculate climate risk. And then a demonstration of our Climate Wisdom product. And then some examples of how we've actually used those methodologies and our data and our systems to actually calculate climate risk on a couple of companies. I'll actually walk through it, at least one of them from end to end, so you can understand what that really means. And then I'll open it up for any questions for anybody. To start off with, we're riskthinking.ai, and just to our company delivers the data algorithms and the analytics for actually measuring exposure and financial impacts of climate change. The team, me in an older picture, I'll update it. But it really, risk thinking is the culmination of three senior level people. I think we've almost got 100 years of combined experience. Ron Denbo is the founder. Ron brings the financial engineering and risk view to our company. Ron started his career at Yale University and then built a company called Algorithmics. And for those who don't know it, Algorithmics was started in his backyard and actually became the largest enterprise risk software company in the world. When he started it, there weren't even any chief risk officers in companies. He basically defined the industry. 70% of the top 100 banks in the world, 4 out of 5 of the largest insurance companies in the world, all used Algorithmics to calculate financial risk. And it was all scenario based. So he really educated the industry on how to look at risk. My background is 30 years in big data and AI. I started my career at EMC and then built a few companies. Most of my career, 15 years of it, was with a top secret security clearance, building large, very large infrastructure for data analytics. I worked at the FBI, CIA, NSA, DLA, DITRA, DOD, and others. After building a company and taking it public and selling it, I went back to Harvard Business School. And for the last couple of years, I've been building AI platforms and data platforms. And you'll see how my background is leveraged to build the product that we'll demonstrate today. Andrew Wiebe is our chief science officer, and he's got 25 plus years as a climate scientist. He's also leads our software development and builds supercomputers in his spare time. He's a brilliant climate scientist. So we bring the software engineering, the big data, and the financial engineering to actually understand how to calculate financial risk. What I want to start off with is kind of, for those who aren't really in the space, is to give you a level setting that climate science is really complex, right? But it is fairly simple. It's causal in nature, and it starts with things called climate modulators. And everybody's heard of El Nino. Here's a slide on the Indian Ocean dipole. And what happens is that these climate modulators drive the global climate. They are linked throughout the world. So what's going on with the Indian Ocean dipole has a direct correlation to what's going on with El Ninos in different parts of the world. And what happens is that when an Indian Ocean dipole is pronounced, it actually causes drought. It pulls moisture out of the air, and causes drought in Australia, and it takes that and dumps it into Northeast Africa and parts of Asia. So it is very causal in nature. And what happens is that you have to understand how these things are connected. And it's not just the weather, but how they connect to financial systems and society as a whole. As an example, here is, the Indian Ocean dipole was very pronounced in 2019. And what occurred is you saw massive wildfires in Australia and actually flooding in East Africa that caused migrations of individuals and everything else. And over 2.5 million people were affected in Eastern Africa. And that's all because of a weather pattern, right? So what we do is try and look at those weather patterns and how they affect society, but also climate is not just that. It is, when we talk about climate change comes from a number of different areas. And when I say climate change, the risk from climate change on assets, societies, countries, and others comes not just from that, but it also comes from the policies that are implemented to try and impact how climate change will affect us. For example, things like President Biden saying we will go to a zero carbon grid by 2035. That's actually affected, that is part of climate change, and it has a deep and profound impact on lots of assets. For example, how would you like to own a coal-fired power plant in Wyoming, or a bond on that, or an equity of a company that owns that, when a policy change of a zero carbon grid by 2035 is actually put in place? What that means is that coal plant will not be able to operate after 2035. So if your bond expires in 2045, it's that, just by that, making that policy, assets and industries and sections of the country are impaired by every policy, and those policies are climate related, so they all fall into climate risk. As an example, net zero by 2050 is a climate policy, and you'll see that there's all sorts of things that are put in place to try and get to that net zero that affect policy, economic conditions, and those trickle down all the way to socioeconomic conditions for different organizations and regions of the country. So it all comes into play into climate risk. So if you're just looking at companies that say, oh, your climate risk is flooding or sea level rise or wildfires, you're, in our view, you're missing over 80% of where climate risk actually comes from. So what's needed to really understand climate risk is, first, a great understanding of the climate, right? It all starts with the climate and the globe. But you have to understand the past, but you really have to understand the future. And since climate change has not occurred in the past, we've never seen sea level rise and storms at this level. By actually looking at the past to try and forecast the future, you can't, because the world is changing. The past is not indicative of what will happen in the future. So you have to actually take all of that into consideration. And as I said, things like policy, economic, carbon risk, physical risk, and social risk are all connected, and they're causal in nature. And I'll kind of get into that a little bit more in my presentation. All of the data needs to be aligned, and you have to actually understand those risks. But climate risk is actually temporal and spatial in nature. Climate occurs in a particular region, in a particular location, and you have to actually understand. You'll see this picture on the right. What we do is that we've actually mapped the world. And in our map, there are 33 billion hexagons. In every one of those hexagons, we map the historic and the future, and all the variables that impact that location. We map all the climate variables, all the socioeconomic variables, policy variables, that actually can impact every one of those regions, so that when we look at a particular asset, a house, a building, a community, or even a country, we can understand all of those variables and how they can impact assets and anything that sits within those, including supply chains, right? So to do this effectively, you have to do it in every corner of the world. You can't do an analysis and say, well, let's just look at the United States, grab as much data as you can on the US and understand risk, because everything is connected. Companies are connected, industries are connected, supply chains are connected, government policies and everything are totally connected. So to do this effectively, you have to collect the world's data and you have to connect it. You have to understand the interconnections with all of these. To do that takes mass amounts of data. You'll see in our system, it's over 5.5 petabytes. And you have to algorithmically generate all of these things. So it's not humans taking into consideration what the future will look like. All of this needs to be algorithmically generated so you can do things consistently across the world. To do that is a difficult task. In the past, there have been no standards to align data. How do you align climate modulators with financial factors? And the fact is to do this, new standards had to be created. So in a different presentation that we'll schedule in the future, I'll give a whole presentation on CRCS, which is the Climate Risk Classification Standard. And it's a standard that we've created to codify all of the climate components that are used in climate risk analysis. And so we've codified the Indian Ocean dipole and all the climate modulators. There are 39 of them. We've codified all of the risk variables so that now once it's codified and put into a structure, you have the ability to build mathematical models, right? And until now, there was no way of doing that. You'll also hear things of the European taxonomy and different taxonomies. And basically what that means is everybody just created their own language. To create a standard so that you can actually look at risk across the world, if you've got assets in Europe and the US and you've got different regulators looking for responses, you have to have a single mechanism that talks all of the taxonomies. So CRCS allows us to align the different taxonomies and deliver different factors into a consistent basis. We've taken CRCS and we're open sourcing that so that people can actually use and leverage that standard for future analytics across the world. In addition, why we open source that and look at it and provide all of the data, and you'll see in our system, everything needs to be transparent, right, and consistent. So there can't be a black box here. You can't actually just publish a particular number and say your climate risk score is 42 or your ESG score is a 71, or because it's meaningless unless you have all of the information and people can actually really understand every component, where the numbers came from, and how you did things, so that there's a backing to everything that you do, and people can understand where it came from. So to do that, we've created new ways of measuring and actually rating risk, and I'll go into that a little bit differently. The real view of that is that climate risk is stochastic. We don't know what the future will look like. You can't choose to identify risk based on one potential outcome in 2050 because you'll be wrong, right? So you have to look at things in a very stochastic way. So you need systems that actually take into account radical uncertainty. So in our system, to do that, I've said we've mapped everything to hexagons, but then we have the ability to look at everything under multiple scenarios. So for every hexagon there's over 500 different variables that are mapped here, risk factors. For each hexagon there might be, and I just picked out 25 key risk factors that can impact the assets in that region. what happens is that if you just look at 25 and then the number of scenarios that generates on the potential distribution risk, you come up with 33 million scenarios that you're looking at that can impact an individual asset, right? And then if you look at that and you've got assets everywhere and you look at it across, we have actually 33 billion hexagons, and we'll show that in our demonstration. That's actually mapped for every period of the world under every different pathway of temperature, a 2-degree world, a 3-degree world, a 4-degree world. So in our system, we actually have trillions and trillions of data points that are used and algorithms that can bring all of that instantly into bear to understand and calculate risk. It's a monumental task. The way that we structure things, and if you don't understand transition scenarios, and where climate data comes from. So climate data comes from transition scenarios, which are a socioeconomic view of what the world will look like at points in the future out to 2100. Organizations like IPCC, NGFS, the Bank of England, IEA, basically create these massive models that predict what GDP in France will be in 2050 in a 2-degree world, and what it would look like in a 3-degree world or a 4-degree world. And they create all of these pathways. Currently, we have about 74 of these massive models that have been put together by these global organizations, the United Nations and others. And we collect all of that data and align it so that we can understand what the consensus view of these organizations is for socioeconomic conditions. Inside of all of those are those economic drivers. There's macroeconomic variables. In NGFS phase 2, there's over 1,700 variables. What we do is we look at those across all of the transition scenarios and identify the consensus. So across all of them, there's about 500 variables that show up in 50 plus scenarios. So what we do is to say every transition scenario that is published today is wrong, and we can prove it. But collectively across those 50, if we look at all of them, we can look at a distribution of GDP and what 50 people think the GDP will be in France in 2050. And instead of just picking one number, we look at that as a distribution that it's somewhere between X and Y. And based on that, you have a different view of calculating your risk profiles, right? That doesn't go to just GDP, it goes to population growth, energy price, crop production, and so on. So all of that is calculated. There's 1,000 variables that we calculate, and we create at the end of this a multi-model economic distribution on every single one of them, aligned for every hexagon on the planet, right? Now, if you look at transition scenarios, there's actually only one variable within a transition scenario that's actually climate related. And it's how they align those transition scenarios to a global mean temperature. So they're looking at a 2-degree world or a 3-degree world, but then how do you actually map that to the climate models? And the way that's done is by actually taking the transition scenarios pathway and aligning it to a representative concentration pathway. So basically, there are 9 pathways that are a distribution of temperatures that organizations like NASA, NOAA, the China Meteorological Group, European organizations, Canada, these are massively funded global organizations that run these models that take supercomputers months and months to create an output that looks at what the world climatology will be in 2050, 2070, all the way out to 2100. So we take all of those in every model and bring it into our system. And again, like the transition scenarios everyone being wrong, every climate model that exists today that's available is actually wrong. And by the time that it is run and published, science is moving very quickly in identifying how climate change is accelerating or decreasing in different areas. And I'll give you a perfect example. All of the models were run prior to last year. In January of 2021, scientists identified that the glaciers are melting 6 times faster than what was previously predicted. That actually provides a change to sea level rise, ocean solidification, and other variables. So when NASA, NOAA, and China, and everybody else were running their models, they took certain assumptions that now, with the latest science, are wrong. So if you're trying to pick and use just one model, and you're planning on building something that could be impacted by sea level rise and others, your risk analysis is wrong. So again, like this, we collect all of those variables. We create these distributions that you see on the right, but we use machine learning and artificial intelligence, as well as knowledge graphs, to collect the latest science on every risk variable. So we've trained it on our CRCS to look for sea level rise. So we read 250,000 peer-reviewed scientific journals and papers on a weekly basis to identify what the change in science is saying and how those changes can impact climate risk. And we bring it all into the system. So again, monumental task. What we also do is that we take a very different view of climate risk. I started to allude to it at the beginning of the presentation. Climate risk is just not sea level rise, or how many more hurricanes are going to hit, or where droughts are going to be. All of these variables align to certain risk macro factors. So we've taken all of those variables and we've aligned them to these 5 factors. And they include policy risk, economic, carbon, physical, and social. And you'll see in the presentation how we basically take these to understand how there's a correlation or a causal effect with all of this. And I started by saying, look, policy, you set a policy of zero carbon by or net zero by 2050. To meet that, you automatically introduce carbon exposure, because the only way that you're going to meet that is by actually having higher carbon tax, right? If you want to move that and say we're going to hit zero carbon or net zero by 2035, those taxes go up dramatically. If you look at all of the transition scenarios and you delay and you're not putting policies into effect now that you should have, then by delaying those, you end up down a different pathway. And to actually meet the 2050 goals, those carbon taxes, the economic conditions, and all of the components within the risk changes, right? So understanding all of these pathways and how they affect each of these macro risk factors is how you calculate risk. Right? At the end of the day, what that means is that we're taking sector risk, industry risk, location risk, asset risk, macro risk variables, transition risk, and climate risk, and putting it all into very complex mathematical models that create scenarios that look out to the future. And those scenarios, the way that we look at it is that there's a possibility of all of it. We could end up with a 1.5 degree world if we move quickly, or a 1.9 degree world, a 2 degree, a 3 degree, a 4 degree. But by picking one transition scenario and saying, hey, the world's going to increase by 3 degrees, right? You haven't looked at the full distribution of possible outcomes. And our company works with asset managers, financial investors, and we're really looking at climate risk. Climate risk is how the climate affects the value of an asset, right? You'll see ESG. ESG is how the company is actually affecting the overall climate, right? How it's taking the steps to be a better global citizen. What we're talking about today is really how climate and all of those variables, the macro variables from climate, affect the value of an asset, right? This is an eye chart, but this is how it all comes together. You take that transition scenario and the macro variables and the emissions, and it gets completely aligned. And at the end of the day, you end up with thousands of different factors and variables that end up with a distribution. To look at that a little bit closer, underneath all of these different transition scenarios, there's different models. At the end of the day, each one of these, you'll hear SSP 585, which is SSP, and then RCP 585, which is a worst case scenario. It's a 4+ degree world, right? And we then run that through all of these models, which are NOAA, NASA, and others, and get literally a distribution on wildfire, right? So all of that then goes into this alignment so that you can understand all of the risks. And at risk thinking, one of the main things that we have is we have a patent on an algorithm that was created by Ron that allows us to take multiple disparate risk factors, policy risk, economic, carbon, and others, and put it into a automated scenario generation algorithm that allows us to look at all of those risks and create tons and tons of scenarios that look at the opportunities, or it's really the upside or the downside impacts on assets or a portfolio. And at the end of the day, what we end up with is a distribution that can be looked at through this, that you'll see these bars on the right, that we can understand the upside versus the downside. And we've come up with very simple new ratings or ways of exposing that basically in our rating system, we take those, and you'll see this is our rating system. A D5 means the downside risk, meaning is 5 times greater than the upside, meaning under all of those scenarios that were run, 5 times more of those scenarios you lost, and then you gained. So it is not a deterministic rating. It basically says under all these scenarios, good things could still happen, right? But it's highly unlikely. So the definition of this then looks at how that asset or country or whatever we're putting underneath the lens is highly likely to be severely impaired. So if you're a decision maker, you really have to understand your downside and your upside and where that risk comes. And you also, with this, you have to understand what variables is that risk coming from carbon risk or social risk or policy risk, and when is it coming, right? Is it coming by 2030 or 2035? The example I gave on the carbon or the coal-fired power plant, by 2035, that asset could be worth zero. I mean, so when does it come? Well, as soon as that policy gets put in place, it is impaired. How quickly will that asset decline? Well, it'll decline. It might not go to zero because carbon capture and carbon sequestration could be introduced in 5 years from now that allows you to just keep burning coal, but without putting out carbon. So there's always potential upside here. And by using this type of rating, you can understand where that distribution of upside versus downside comes, because in all of these, you end up with this distribution. Our output actually doesn't just look at the scenarios. The way that we do it, it's a probability distribution. So we can understand the likelihood of each of these scenarios and how it will impact assets. Right? So here's a simple, I want to give you an example of how people are using this today. So we made an announcement fairly recently that Bank of New York Mellon will be leveraging this capability, these standards, and these ratings in their system for their clients. So Bank of New York Mellon is the largest custodian in the world. They have 40% of the world's assets under management, a little less than 3,000 asset managers. But the assets under management with those organizations is just over $41 trillion. And that includes every asset class in every sector in every corner of the world. So what they do is that we will be providing climate risk ratings and exposures based on what I just explained to you on all of those assets, so that people can understand that their portfolio is a D2 currently, and where that exposure comes from. It's economic exposure. They're doing really well on social, and they can actually dig into the different variables and understand where risk is and when it is coming from. This screenshot is basically on a net zero 2050 pathway. So really understanding risk and how it might or might not change over time in a very consistent way, right? So at the end of the day, how do you get to all of this data and algorithms and everything else? We've created an application called Climate Wisdom. I'm actually going to demonstrate it for you and walk you through some examples. Here's basically a screenshot of a stress test, and I'll show that to you live. But ultimately, this is a regulated or soon to be a regulated business. It's regulated in certain parts of the country, and organizations are mandated to actually provide an overview in disclosures of their financial risk as it relates to climate change. So this is brand new, and it's been very difficult for people to understand how to calculate that. Risk Thinking, we believe, is one of the first organizations, if not the only one, that can actually do this effectively on all different assets in a consistent way across the world. So I'll actually start a demo here. Quickly, are there any quick questions on any of that? Amy, how did I do?
I have you muted because someone just got to my house and my dog is barking. But actually, you did great. Thanks, Brendan.
No worries.
Yeah, really helpful, Brendan. It's very clear, and I learned a lot. So thanks. That's encapsulating it very good for the layman in this group.
Fantastic. So let me let me go back to this screen, and I'll go over to a demonstration. Okay. So basically, what you're seeing is Climate Wisdom, and Climate Wisdom is really designed. Can you see this? No.
Not yet.
How about now?
Yes. Or it's loading. Yeah. Yeah. Clear.
There you go. Okay, great. So Climate Wisdom is designed to be the central point for accessing the data needed for clients. Right? We originally, as a company, were going to put out and be the consulting company and that gave you all the ratings and everything else. We quickly shifted to focusing on the problem in the industry, and that's the data. And then being the organization that allows all different companies to basically grab the data and do their own calculations. What you're seeing is the data exchange, which has over 80,000 data sets. We're about to do another update in the next week or so that will increase that to well over 120,000 data sets. Each of these data sets includes the global view and global distribution of every variable within here. Everything is global. You can look at things at a country level, a region level. We look at everything under every scenario. So you can look at things under NGFS or IPCC or other scenarios. You can pick one and see all of the individual socioeconomic variables that are mapped around the world from these scenarios. And then you can look at things from a risk factor standpoint. So I just want to see sea level rise, or I want to see biodiversity loss, or mean temperature, or wildfires, or droughts, or heat wave stress, or others. And you see that over certain individual timeframes or annually. The system allows you to go in and just look at wet bulb under SSP 585. There's 40 data sets, and you know what I'll do is I'll look at it on a annualized basis, and there's 19. I can pick one, and what this is doing is it's giving you what the world view is from all of the different climate models. Say wet bulb temperature will look like out into the future. So this is every one of the different models. And that will come in. Let me just, they're not out to, so if I look at different time periods or different models, you'll start to see how they differ in their view of what the world will look like going forward. I think there's a question. Really? Okay, so, but
I think, Brendan, you opened the queue.
Can you hear me?
Yes, I can hear you now.
Okay, thank you very much. I think my question was, I was referring to how your bank's clients use this data.
Watch this. I'm gonna show you.
Okay, because for me, I'm a risk manager, and my objective is to estimate the potential risk.
I'm going to show you exactly how they do it. So what we do is that instead of just giving you that score, we actually give you all of the data underlying it, so that it's what we call regulator ready. If anybody looks and says, well, where'd you come up with that number, right? How did you calculate that risk? In this system is all of the data to back up every single number that you'd ever want to put out, right? And in this, the ability to do that all algorithmically, and I'll show you what I mean. In every data set that we have, it's all API accessible, but here is the description of the data, the attributes, the index description, the institution where the data came from, the licenses for the data, and even the sources of the data. We even give you the URL of where to go get that data, right? If you want to go get all 5.5 petabytes, good luck. But we've basically done that in a way that you can go get that. Now, to your point, how is this used? So you can look at things under different scenarios. As a bank, you can actually load your own scenarios. But the way that people use it is, and I'm going to walk you through Tata Steel. And then how you look at Tata Steel is I'll walk you through how that then looks at Tata Equity, and then a portfolio, and then decision-making process. So the other thing that we can get into, and we're going to do another presentation, we're doing an analysis for a number of banks, one of the top 3 largest banks in France, one of the largest banks in Canada and US, and doing a climate risk analysis on every one of their mortgages in North America and commercial buildings in Europe. So basically what that means is that you have the ability to load assets in here, and those are physical assets, or we do equities and other things. This is the example of Tata Steel. These are their assets. These are research facilities, manufacturing facilities, open pit mines, everything. This is just loaded as a CSV. As soon as it is loaded, you get a API to the data. What that allows you to do is then go into the system and then actually look at the risk variables that are associated with those assets. So I've just picked 3 previously, but this is an instant process. You can choose what variables. Automatically, we have a system that allows you to calculate all the risk and get the output, and then you can go in and see where all of that came from. But just to show you the granularity here, these are those assets, and I'll just turn it off. Every white dot that you're seeing is a Tata Steel location and asset, right? What we're doing is layering on to those assets the risk variables. So this is heat wave stress and sea level rise and policy risk and carbon risk and others. And they associate, see these hexagons are the different climatological or socioeconomic regions that can impact that location. They scale again down in size to very small hexagons, whereas this asset, this individual asset, could be much more susceptible to river flooding than something else. So we go down again from 150 square kilometers down to potentially half a square meter based on the risk factors, right? So now what happens is that you can do a full stress test on those assets to understand where the risk is coming from with every asset. And I'll give you an output, right, which is probably a better look, because this is we just put a CSV output that we put into the system. And what you're seeing is that these are those assets that I showed you that were uploaded into our system, right? At the end of the day, each of these assets is exposed to a policy, carbon, economic, climate, and social exposure. Collectively, they have they get an overall exposure score and an overall rating, right? So some assets are much more susceptible to physical risk. Other assets are susceptible to policy risk or carbon risk. And I'll go into that in depth. And what that means is, for example, here is every one of those assets and how is it exposed to river flooding and drought and heat wave stress and others. So basically you can look at every physical risk that can be impact those assets and look at, and then say, look, I'm the asset manager. Give me all of the assets that aren't impaired today or aren't impacted by flooding that with climate change will be in the next 10 years, because I'm going to issue 30-year mortgages. And if those houses are then in a flood zone by 2035, they will be worth less money. They will be impaired, right? So we want to know where these, even if it doesn't get hit with flooding, and even if they have insurance and they're going to pay their mortgage, the fact of the matter is if it's a flood zone and the entire region is impaired from the value of those houses, then you're highly likely for those or higher likelihood of people walking away and not paying their mortgage, right? So we look at that, things like carbon, and this is carbon price. So we did an analysis on US Steel and an investment in US Steel or a loan to US Steel versus Tata Steel. And what you end up identifying is US Steel produces $451 in earnings today for every ton that they emit in carbon. When you go right now, the current policy for the US of carbon price is $3. There is no national carbon tax, right? It's trying to be proposed, but it's $3, and it's only $3 because there is a tax in California and parts of Virginia, right? But nationally, there is not one. There are some carbon taxes in other places. But when you start looking out and you say, well, the US is going to be hit with a $93, it's going to be much higher, right? And at the same time, India is going to have a $30 carbon tax that really disadvantages US Steel, right? And as it goes on, if you look at it, and when the US is going to have a $918 tax, which could be much higher, that we're modeling out under certain things, then I just told you that US Steel produces $451 of earnings. So at a certain point, US Steel cannot actually produce steel in the United States. And what happens is they're not going to be hit. Other countries are not going to put the same level of carbon taxes or restrictions on particular industries. So on a global basis, US Steel will not be able to compete with a Tata Steel. So what we're doing is just taking all of that into consideration. The other thing that we're taking into consideration is as we map all of these risks, including socioeconomic risk, is understanding, when I said a flood, is the resilience of that community's ability to rebuild or continue to pay their mortgage after a large disaster, right? In my town, most of the people are capable of rebuilding. But in 3 towns north of here, I would say 90% of the people would not be able to rebuild in certain situations. So the other mapping of the socioeconomic is, how would you like to be the individual giving out a 30-year mortgage on a home in the Pittsburgh area that is completely reliant on income from a US steel plant that may or may not actually be able to operate. And in our estimation on all of these scenarios, they will be severely impaired. And if they pull out, and everybody knows the stories, there's Pittsburgh towns that literally went bankrupt. The plant closed, and you couldn't sell a house. The McDonald's in the community couldn't actually even operate. So what happens is that you have to understand, when you're issuing that mortgage for 30 years, that there is climate risk, because these are climate risks. It's not that house or the factory is going to be hit with flooding or heat wave stress. It's that it's going to be impaired because of policy and carbon risk and economic risk, which is going to cause social risk, right? So if you're not looking at all of these factors and taking it into consideration, you're actually missing really the full spectrum of what climate risk is. Did that answer your question?
Yes, yes. Yeah, it provides some information. Yeah, I think this
Yeah,
is.
so ultimately, you'll get on every equity, every asset, every sovereign, right, an overall score, right? And they'll all be calculated the same in every region of the world. And you can say which ones, are exposed to what variable and over what time. Some exposure is not going to hit until 2030, 2040, 2050. So do you want to divest, or do you want to look at the risk, and it's in your organization understanding that risk and the magnitude of that risk and making informed decisions. And without this level of detail, I don't know how anybody makes an informed decision. And let me give you a perfect example of, I said that every transition scenario is wrong and every climate model is wrong. I told you that those transition scenarios look for a carbon price in Europe of 100 euros by 2030. Right? 3 weeks ago, in an auction, carbon prices went for over 100 euros. So if you pick a transition scenario and say, I'm going to do this TCFD, or I'm going to follow this IPCC transition scenario and look at my risk, you're wrong, and you have to understand and disclose that transition scenario is wrong, because it's provably wrong. What we're trying to do is look at those and say, look, it was going to be a carbon risk by 2030, right? That happened today. So all that risk is shifted to the left, right? So your downside moved to the left, and you've got smaller upside, right? So we're providing the data and a mechanism that allows you to look at that risk, and then make intelligent decisions based on being well informed, right? Hopefully that makes sense.
Yes, I think it makes sense. So you provide a range instead of one single point or data point. So
exactly.
That
looks like
allows
this.
to see the spectrum and make decisions. That's true. Yeah, agree.
Yeah, and all of the output is a probabilistic distribution. And so we end up with this distribution, and based this line between the red and the green is your target. And this is net zero by 2050, right? If all of a sudden I said net zero by 2035, this line moves to the right. The risk didn't change, right? I mean, each of those variables and the risk to every variable of what the future would be underneath all these pathways is the same. But the fact is that you're shifting your risk. It's coming sooner, right? Or coming later, right? Carbon tax will go up. At what speed, I don't know. GDP will be impacted, social components are impacted. So we're trying to track all of these and give you the way to look at it in this stochastic view, but in a way that gives you the data and the details needed to meet regulatory requirements, to talk to the board, and it's not 6 people sitting around a table saying, hey, we're fine, our risk level is a 17. I don't know what that means, but we created our own scoring mechanism. So look, we think that this is the right way right now. We align those 5, I have people say, well, why didn't you take one of the factors and look at technology risk? And the fact is, technology risk is on carbon sequestration and other things. And in our carbon risk, what you see is it's not just based on price. There are 21 carbon variables in a climate index that we look at to calculate the climate exposure score. And what we're doing is that if in those models, in the transition scenarios, there's assumptions of large drop-offs in carbon output, the only way that those could have actually been modeled is with the introduction of new technology on carbon sequestration. So I don't know if you heard the other day, but Elon Musk just put up a X prize of $100 million towards carbon capture, right? So hopefully that will entice people to understand and create new technologies that can take carbon out of the atmosphere and alleviate certain levels of these overall risks, right? But if it is, it's captured in the system, right? So we have just a few minutes left. Are there any other questions here, or?
One of the challenge we have is if you have a corporation that's exposed to those risks, and you do the analysis and you find out the range of risks you have, potentially the response for that corporation to adapt or to mitigate that risks, how do you take that into account to improve things?
Yeah, so fortunately, we're not insurance. We're not looking at things, of your risk for next year, right, from flooding. Our model is longer term. So how do you do it? I mean, you can take actions and you can take steps to start mitigating your risk to future climate change that could occur in 2030 and 2035. So if you're not looking at these things right now, you're not going to be able to see what's coming at you. So this gives you that lens, and you can then understand if you're Tata or US Steel, you're saying, oh crap, hey, you know what? I'll probably need to look at the ability to either get carbon capture really quickly, or maybe as I'm investing, I need to invest in building a steel plant in Mexico, right? Or somewhere else if I'm going to compete on a global basis. Or maybe I actually put a plant in Africa somewhere or somewhere else, because they ultimately have to produce steel, and based on the restrictions of carbon output, they will be impaired, and they will be non-competitive to countries or steel in China and India and other places that are not going to take the same approach to, the climate or climate change. So you're going to look at that. You're also, if you're a bank and you're understanding, potential flood risk, or not even flood risk, but FEMA hasn't updated their flood map of what flood zones are. And if your house is in a flood zone, it needs to pay higher tax. And my wife wouldn't buy a house in a flood zone, right? So when those flood zones start expanding, we're actually showing you where those flood zones will actually expand to based on all of these different scenarios and the likelihood. So maybe if you're going to issue a mortgage, you might want to take some of those things into consideration on the value of the house, right? So it's just building these things into your models. And the way that we do the outputs are all API based, so that you can actually look at those distributions and do analytics on it, on where you want to embed that into your analysis. We're working with a Canadian bank that is building climate risk into loans, into basically everything that they do.
One question. Just
Yes, sir.
really appreciate these examples that are both industry-based and sort of banking issues. What about the higher level conversation at central banks and, more, not so much macro, but international implications with how countries are going to be, whether legislating or regulating? How do you think that's going?
Yeah, so we will put out some climate risk ratings on sovereigns in the first quarter, and we'll start to publish things. You'll see it in many different places. Although we're a small company, in the next 90 days, you'll see that we will potentially have a profound impact on the industry. And what that's going to do is that there is not enough talk about how policy and some of these things will actually impact socioeconomic conditions in different regions, but within minority communities and others around the world. So we are talking with regulators and central banks right now to hopefully embed this thought process and the data so that they can understand the correlation of potential actions and how they, not because we don't talk in deterministic ways. It's not like, hey, if you do this, this is going to happen. But we say, if you do these things, that there's more downside than upside for this community. So you have to understand, and then what are you going to do to mitigate that risk, right? And I'll give you one last example before I go, is that the city of Syracuse, New York, basically passed a law that says you cannot heat your home or business with oil heat or carbon producing heat sources after 2030, right? So I just moved from oil to natural gas at my house. It costs $9,000. If you're a middle class or lower middle class person who owns a home, I don't know a lot of people who can just fork out $9,000 to go just change now, right? So what happens is that those homes that have oil versus natural gas already are instantly impaired because I don't want to buy a house because I got to put the money in and I got to do all this other stuff. So it also puts that economic burden on communities that may or may not have it. So there's a real impact here, and people have to understand where that impact is. And again, I'm not talking about there's going to be flooding or sea level rise on Syracuse. The fact is the climate policies and economic components really are what will impair and impact values of assets, right? So our goal as a company is to do things like this so that hopefully somebody on this call goes to a central banker that they know and goes, wait a second, guys, you haven't seen that you can actually have all this data and it's already aligned and you can start looking at it. And are you looking at the social impairment and other things? So the goal is we will start to do these as a series of events and hopefully, get to the right individuals and people that have the mind share that can make these decisions in a much more well-informed way.
Yeah. You're giving them all the tools they need, so well done.
Any other questions or comments? Great. It's 12:01. I appreciate everybody attending and have a wonderful day.